how will we select lambda? I've written here the cost function formula that we've seen many times before, mean squared error function, and then I added this regularization term, which in this case is rich regularization, because we take the L2 norm of the weights and we square. So weights higher than 1 will be penalized. We prefer weights close to 0, small. Now if lambda is 0, this term disappears and the training error is likely to be low. Because that's the purpose of the old algorithm, is to reduce the error. So you'll start here. When lambda is very, very large, this term will dominate. And obviously your training error will be higher because it's a quite simplistic model. So for training, you have a bit of a curve that goes like this. This is how it works in function of lambda. That's your training error. Now when lambda is 0 here, the cost function here is dominated by training. It's obvious at that time that the test error will be higher. So the test error will be higher when lambda is 0. When lambda is very large, again, you have a very simplistic model and your test error will also be high. So in terms of test error, you're gonna get something like this. Okay? Now you see that here there is a sweet spot where your training error is actually minimal. And so we can easily say that this zone here is underfitting, whereas this zone here is overfitting. So it's very important you select the right lambda. And how we will do this is, well, we have what I call a data set. This is your data set D. And what we did in the past, we had a training set. We did a split in training and test. But now we're going to make another split. So this will indeed be test. But before we test, we will what we call cross-validate. And the cross-validation set is used to determine the hyperparameter lambda. If your training set is small, training set, sometimes what people do is k-fold validation. You have to be careful, because if you do a lot of action on your validation set, you're also gonna tend to overfit. So one way to avoid that, especially if you have a small data set, is that you split your data set into, for example, 5 pieces, and you do 5 runs. This is cross-validation, and in the end this is cross-validation. So you change your cross-validation set as you do multiple runs. So you will see this in some of the algorithms. There is a parameter called cross-validation equals to 5. 5 is a typical number that is used.